Okay, what we've got here is a heat engine. Actually, a lot of the work done on this is by a guy called Attilla. Okay, so it's his metronome heat engine, in fact. Now, I've put it onto a hot pan to give it a bit of quick heat, and what we've got attached to it is this bit of tube here. And this bit of tube is the moment full of air. I can fill that with water, and when the engine is going, it will pump the fluid backwards and forwards, which of course is exactly what I want, because I wanted it for the swag generator. So the idea was to put some low-grade heat in there and have something that would pump. But actually, it's really quite cool. So if I get that going, I have to hold it because it jumps. That will just flood away as long as there's a temperature applied to it. And that's about 300 degrees, incidentally. Now, as I say, what's happening in here is this air is swashing backwards and forwards and acting like a valve, if you like. And we could equally put water in it. But I made this deliberately with this big old rod sticking out here. And the reason I made it with this big old rod is because it's obvious. If you stick a magnet on there and a coil around it, then we could use that to generate energy as well. Now, I've just done it like this because it's quick and simple. But obviously the temperature here isn't too different from the temperature here. And if I put a water jacket on there, I'll actually get a much bigger movement on this. It's just I wanted a simple engine for you so that you could see how easy it was. And it really just chugs away as long as you apply heat. That's actually very cool. Easy to stop, you just stop it and then start it again. Very, very cool. I'm very pleased with it. Now, like I said, the rest of the video is going to be entirely on how to make this. So, in order to do this project, you're going to need to get some things. Of course, unless you already have them. And the first thing you're going to need is a canister. I went down to Asda and bought this. It's a food container. It's stainless steel and has an acrylic lid. Now, you could equally use a paint can. It doesn't really matter. Just a canister of about that size. So I guess that's about 1 litre, something like that. You're going to need some threaded bar. Now this is 6mm. It's only 6mm because that's what I thought I would need. 8mm probably just as well. 4mm probably a bit too thin. 10mm probably a bit too thick. You're going to need some nuts to fit. You're going to need some repair washers. You're going to need some tap washers, which are neoprene rubber. And you're going to need some kind of copper fitting. That copper fitting should be about 15mm on the bottom. And then the top bit is going to depend on the next thing you buy, because you're going to need a length of tube. I've got 5 metres of 10mm external diameter, 8mm internal diameter tube, and that stuff's just nicely in there. If you have different tube, you're going to have a different fitting, so this tube will stuff into the fitting. The other thing you're going to need is something like that. This is a plastic pot. I have quite a lot of them. And the reason I need that is I'm going to have to glue it onto there. If you don't have a plastic pot, you're going to have a ring of some kind that will go onto the top of your canister. So that basically are the bits you need. Oh, one more thing. You need a whole load of wire wool. So just get yourself some wire wool. And those are the bits that you basically need. Now, a few other bits and pieces will be required as we go along, but they're just going to be things that you scrounge up, and you'll see what we need when we come towards finishing it. But those are the essential basics. Okay, so for the Stirling engine displacer, here's the actual body of the Stirling engine, about 4/5 of the way up, and you just gauge it by eyes where the displacer needs to come. Now I've got a bit of 6mm threaded bar, popped that in there, and at 4/5 I put a bit of tape on it so that I know where to wind the displacer to. And the displacer is made out of steel wool. This is a medium grade, and it comes as quite a tight bound, and you have to unravel it until you get it in its single layer. And there's a load of it. So I've got mine on the floor, and it's going to shed little bits of steel absolutely everywhere. So don't do this in your living room or you'll be hoovering it up forever. And all you actually do is wind the steel wool onto the displacer, making sure that you even it out as you go along and keep winding, not going much past this marker that you put. When we put a washer and nut on there, it will compress it a little bit, so you don't need to be too worried about it, and keep on winding it around, spreading it out to make sure you get an even plug, because what we're going to do is make that so that it slides in and out of there freely, and you keep on winding until you've got roughly the right size. So there we go. It's a little too big at the moment. but I can moderate that and snip that off. So what you end up with is this. Now I've put a nut and washer on there to hold it in place, and a washer that's quite tightly fit on there, and I've managed to twist that washer on, so we've got our displacer. Now it's quite a tight fit, you can see that it doesn't go up and down easily, and that's because all of these fluffy bits get in the way. So what we need to do is trim those fluffy bits off. You just take a pair of scissors and trim it round until it's nice and neat, and all those fluffy bits have been cut off. So what you'll end up with after you've finished mucking around with it is this, a stainless steel canister, and in there a plunger made out of steel wool that fits in quite nicely and is quite free to move up and down, filling about 4/5 of the canister. So having made our displacer so it fits nicely into the canister, what we need to do is modify that, because obviously we've got a great big rod going up through there, and that won't actually do. Now we need to make an opening in there for a diaphragm, and that opening should be 46% of the diameter of this, so that's going to be around about 42 millimeters. Now as luck would have it, that internal diameter of there is about 42 millimeters. Again, you don't need to be too anal, somewhere round about there is going to be good. So what I did was saw the bottom off of this, and then using a hole saw, cut a hole into there, and glued that onto there to give me that. So that now neatly fits on there, and I've got my chimney where the rod can come through, and that's where the diaphragm's going to go on. So I don't think this next step is strictly necessary, but I'm a bit worried about the seal and the fact that this is quite thin acrylic, and I also have an awful lot of this stuff lying around. This is fiberglass. It's a body filler kit that you get, so you can fill car bodies with it, and I use it for all kinds of stuff. Having a load lying around, I thought I'd use it here. Now what I'm going to do is fill this area with a load of fiberglass and put my copper pipe in there at a slight angle, and then drill through the copper pipe into there. But the stage I'm going to do now is fill that area with fiberglass. And like I say, I don't think you strictly need to do it, but it will make it easier for me to make this, and so many of these things are just made from bits you have lying around. You don't have to go out and buy this stuff so much. Some of it you do, like I said, the essential stuff that I showed earlier you have to buy. Some of it, you just have it lying around, so you use it. So you get a dollop of your fiberglass and some hardener, and it'll give you instructions on how much hardener to use to how much fiberglass. Mix it up and smear it on. Now you'll notice I've got this white ring here. That's going to be a locking ring, and I made that because that's the tube that I used. So I cut off the bottom and cut off the top, and I got this nice tube with the white locking ring. I'm going to leave the white ring in place to make sure I don't get any fiberglass on the threads. Then when you're happy with it, just leave it to turn. So there it is with the top all finished, and it's copper fitting on, and it's been drilled through and neatened up there. So the next bit we need to make is the diaphragm membrane from here, and we make that from a latex glove. Now you don't have to use latex, you can use anything that's stretchable. A balloon will do it, but I've got latex gloves in loads of them, so I'm going to use a latex glove. Now the first thing you do is glue one of your washers onto the latex using crazy glue, cyanoacrylic glue, this stuff. Then there's lots of ways of doing this. You either cut your hole and glue your washer over the hole, glue your washer on, and I burned that out with a soldering iron. You take your other washer, put a bit of glue on it, line them up, and clamp it down, because this stuff works best if it's in tight contact. then just leave that to go off. Here's the bit I consider the tricky bit. We've got to get this membrane onto here and have it lay perfectly flat. Now, it's going to be helped enormously by using a rubber band. So slide that down. And you can see it's fitting quite nicely. Take the rubber band, pop it on quite a long way down, and then pull the rubber so you don't get any creases in it. Now I want to take our locking ring and put it on there. Before we do that, we need to put a bit of crazy glue onto the locking ring and snap the ring into place. And leave it to dry. So there we go. So this is obviously a learning experience for me as well, and as you can see it's chugging away as the heat goes up. But some of the things I learned from it were that the length of the hose actually has quite a big impact. If the hose is too long, it won't work. This is about 1 metre long, incidentally. The position of the displacer in here also matters quite a lot. It should be midway. If you get it too low, it won't work. Too high, it won't work. You need to hang it midway. The other thing is you need to make everything sealed. I was getting leakage problems on my white locking ring, so as you can see I've gone round the whole thing with black tape to make sure it's sealed. The other thing is the strength of the diaphragm. I used a latex glove and that pulled the whole displacer down, so it wasn't strong enough. So in the end I replaced that with a rubber balloon, and as you can see it's now working really, really well. So those are the things to bear in mind. It's tuned by this. The position of the displacer is important, so is the strength of your actual diaphragm. It has quite an impact on the performance of it. Anyway, I hope that was fascinating to you as it was to me. The next step obviously is to make that into an electric generator and put a water jacket around it. And thank you very much for watching.